Actually, in graph theory, this is called a node. These dots are called nodes, and these are vertices or nodes. So then they are connected. Okay, they can be connected. Even if they're not connected, it's still a graph. But let's make this connected. So I connect point A or node A to point B. Okay, and then C we leave it unconnected. Or we can also make it connected like that and like that. Okay, but let's not do that. So this is a graph. Now what this shows you is that you have point A and point B, and there's a link between them, so they can communicate. Basically, if you're standing at point A, you can, through this line, you can come to point B. This line is called an edge. Okay, so through this edge you can go to B, but you cannot go to C. There's no path leading you to C. So this is basically what a graph is. Now in graphs, there's different types of graphs. One is a directed graph, the other is an undirected graph. The graph we have right here is an undirected graph. What the difference is this: if you want to go from point A to point B, A to B, or back, you can go both ways. But now here's the thing. Then you get something called an undirected graph, or actually a directed graph, sorry. Okay, like this one. So in a directed graph, what this means is that there's arrows. So you have a node, you have another node, and you have a link or an edge between them, and you have an arrow showing you that it's one way. So if you're at point 3, right, and you want to go to 2, so you can only come from 3 to 2. You cannot come back. Okay, so it's only one way. So that's the thing. Undirected graphs versus directed. An undirected graph would be this one right here. You're going to see this a lot in our upcoming videos. So this graph just shows you can come from 0 to 8 and back. Now, question is, where do we use graphs? Right. Now, we use a graph in, for example, a road network, national roads. So you want to maybe find the shortest path between them. You want to maybe find the least cost effective or the most cost effective. So yeah, that's where you'd use a graph. Okay, you'd say maybe I want to go from London to New Hampshire, and then I want to go from New York. So I'm gonna traverse I'm gonna check different ways which is the shortest way. Now, yeah, so there's different algorithms that you can also apply on graphs. But before we go that detailed, I'm gonna say there's two ways of there's actually many more than two ways, but we're gonna look at the ways of representing a graph. Okay, basically, if you give a graph to a computer, how is it gonna understand that there's a point 0 and 8 and they are interconnected? You cannot give it a picture. We have another way. So there's two ways. One is by using an adjacency list. Alright, adjacency list. And the other way is by using an adjacency matrix. There's also other ways, but we're just gonna have a look at two. If you want me to make a video about the adjacency or the other ways, like there's an incidence matrix as well, then I can definitely do that for you. So thanks for watching.